This is Mr. Arvinson, and in this video we're going to learn about the distance formula. And the central question is, if we have 2 points, how can I apply the distance formula to solve for the distance between them? So I want to kind of give an example and show a picture to go along with this. If I say I have 2 points, we'll do the first one to be 3, 5, and the second one's going to be 7, 2. What is the distance between those 2 points? What's the value of the space between those 2 points? So previously we've learned about the Pythagorean theorem. If I kind of look at these 2 points, I can say, okay, well, there's a certain amount that I'm going to go down between these 2 points, and there's a certain amount of length that I'm going to go across. Well, now that I kind of put that on paper, hopefully you're kind of seeing it jump out at you, but this can make a right triangle. And previously we've learned about the Pythagorean theorem, that's a squared plus b squared equals c squared. And we know that a and c both represent the legs of a right triangle, and c represents the hypotenuse of the right triangle. So let's kind of label the distance down. So if we start at 5 and we go down to 7, that vertical leg is going to be a value of 1, 2, 3. And if we start at 3 and we go over to 7, it's going to be a value of 1, 2, 3, 4. So that means my value of A could be 3 squared. My value of B could be 4 squared. And we use that to solve for c squared. Well, 3 squared, that's 9, plus 16 equals c squared still. 9 plus 16 is 25. That equals c squared. And now we got, again, I always think about what the inverse operation is, but that's the reason we taught it that way. That's why we've been kind of using those words the whole year. If I have some variable squared, well, I got to think what undoes squaring. That is square root. So I'm going to square root both sides. When that happens, this square root and this square are going to undo each other. Similar to what we've done already, like if I have -2 and I add 2 to it, that's the inverse and they cancel each other out. Same thing here, same idea. The square root and square cancel each other out. So that's going to give me just c on my right side of the equation. And the square root of 25 is 5. Just 5, not square root 5. That is a very different number. But square root 25 is going to be 5. So that means the length between these 2 points is going to be, I can erase this question mark, as it is now known to us, it is going to be 5 units. So here's an example. We started with 2 points that we were given, 3, 5, and 7, 2, and we were able to use something we previously learned to determine the distance between those 2 points. But what if I'm given 2 points, let's say just in general, I'm going to do like just a very broad general case without any numbers plugged in. Let's say if I have 1 point over here, we're going to call that one x1, y1. x1 and y1 could be any numbers. And we're going to have another one up here. We're going to call that x2 and y2. And similarly, x2 and y2 can be any numbers you want. And we're going to find the distance between these 2 points. Well, in a similar way, I'm going to kind of use the idea of a right triangle that I had before. And drop a down. So between these 2 points, we want a certain amount over and a certain amount up. If you kind of think about this point right here, well, it has the x value of this one because we went over the same amount as we want before we went up. So this is going to be x2, and this one's going to have the same y value as this other point because it's about the same level up. So that's x2 and y1. And if we want to find the distance between 2 points, kind of like we did back here, we said, okay, well, if I have 7 and I take away 3, I get 4. And if I have 5 and I take away 2, I get 3. Similar idea here. If I'm over here at x2, and I take away whatever the value x1 was, I'll be left with this idea right here. In a similar way, if I'm at y2, and I take away whatever this value of y1 was, that's going to give me this value right here. So let's look at these values inside the Pythagorean theorem, just like before. If I say I got a squared, well, we could say this is a, this is b, and this is c. So a is x squared, x2 minus x1. That value is squared, plus b squared, which in this case was y2 minus y1. That value squared is going to equal this total still of c squared. Well, I can't combine anything because x2 and x1, although they still are not, no values plugged in there. One has a 2 at the bottom, one has a 1, so I can't really combine them. But if I want to solve for c, I can just say I'm going to take the square root of both sides. I'm going to do that, just so we can get c by itself. That will leave me with, underneath the square root, x squared, or x2 minus x1 squared, plus y2 minus y1 squared. And that value is c. Ladies and gentlemen, that is a Pythagorean, the distance formula that we derive from the Pythagorean theorem. Something we already knew up here, we're able to create something new. So I'm going to put down that tile down here, distance formula. We usually like d, so d typically stands for distance, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we've done something on a graph when we kind of graph 2 points. We use that same idea as before and apply a more broad general case. So we didn't know any numbers. We were able to come up with this formula that if we have the values of x1 and y1 and x2 and y2, we can plug them into this. We can solve for the distance between 2 points. So let's look at an example where we're doing just that. If I'm just given those points. So if I'm going to find the distance between -6 and 4 and 2 comma -8. You want to kind of picture it in a graph. You're going left 6, up 4, right 2, down 8. But underneath this, my suggestion is, just as we've already done before, it's always good to kind of label some points. So we kind of make this like x1, y1, x2, y2. And similar before, I always think it's a good idea, just like we did with the Pythagorean theorem, my suggestion is always put the formula down with nothing plugged in. It's just kind of like a thesis statement or opening paragraph in a paper. It kind of starts the paper off, kind of organizes your work. Same thing happens in this. x2 minus x1 squared plus y2 minus y1 squared. See, it's a good idea to put this down. That way you're not going to make any computational errors. And now that you have the distance formula down, you have your points labeled, it's very easy to just plug in the values. We see x2 is 2 minus x1, that's -6, so minus -6. We'll square that value, plus, let's see, y2. My y2 value is -8, so -8 minus y1, which is 4 squared. Maybe it's a good idea to kind of point out over here. We had a minus a negative number, so it's going to be minus the -6. Just kind of just do step by step. I don't want to do too many steps at once, do one then the other. So -2 minus -6, well, the opposite of subtracting a negative is adding. So this is going to be 8 squared plus If I owe someone $8, now I owe them 4 more. I owe them, so negative, a total of $12. That value is squared. Squaring the first, I got 64, the whole thing square root, 64 plus 112, or 144. If I add 64 and 144, let's do that quick, 64 plus 144, it's 208, so D equals the square root of 208. And for this, we can just kind of leave it as an approximate value. So I'm going to leave it as square root of 208. If I use my calculator and plug in the square root of 208, I'm going to get about 14.4. So what I'm saying is the distance between these 2 points is about 14.4 units.